Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this episode of our Deep Learning Indaba Series, we're joined by Osonde Osoba, engineer at RAND Corporation and professor at the Pardee RAND Graduate School. Osonde and I spoke on the heels of the Indaba, where he presented on AI ethics and policy. We discussed his framework-based approach for evaluating ethical issues, such as applying the ethical principles laid out in the Belmont Report, and how to build an intuition for where ethical flashpoints may exist in these discussions. We then shift gears to Osonde's own model development research and end up in a really interesting discussion about the application of machine learning to strategic decisions and game theory, including the use of fuzzy cognitive map models. Before we jump in, I'd like to send a big shout out to our friends at Google AI, which recently opened up applications for its 2019 residency program. The Google AI Residency is a one-year machine learning research training program with the goal of helping individuals from all over the world and with a diverse set of educational and professional backgrounds become successful machine learning researchers. Find out more about the program at g.co/AI residency. And now, on to the show. All right, everyone, I am on the line with Osonde Osoba. Osonde is an engineer at the RAND Corporation and a professor at the Pardee RAND Graduate School. Osonde, welcome to This Week in Machine Learning and AI.
Glad to be here.
Awesome. So you did your PhD in machine learning, and now you spend quite a bit of your time working on the policy implications of machine learning and AI, in particular with regard to ethics, among actually rolling up your sleeves and doing some model development. Tell us a little bit about your background.
So I did my engineering degree at USC, University of Southern California, across town from where I am. I'm in sunny Southern California, in Santa Monica by the beach. But so at USC, I was focused on more theoretical aspects of learning algorithms. So I was trying to figure out how to improve machine learning algorithms, statistical learning algorithms using the careful injection of noise. And it was a very theoretical type of thing. And when I was finished, I wasn't quite sure what to do with myself. It's one of those things where you could either go up to Silicon Valley and do some work for a commercial entity or figure out something to do in academia. I sort of found a halfway point at RAND. RAND is a public policy think tank, although they don't like the word think tank. We do a lot of thinking about policy problems. Our mandate at RAND is to improve decision making through objective analysis. And so I had worked there over a summer while I was in graduate school while I needed money. So I worked there for the summer. And I figured it was a pretty good fit. So I went back there, and it was just around the time when lots of government agencies, lots of people across the country were starting to think about machine learning and the implications. And so I hit the ground running at RAND, just deploying machine learning models to answer diverse policy questions. And my growth at RAND has basically been me using my technical skills, but recognizing some of the normative implications and trying to address them, the normative implications of using AI and machine learning in public policy spaces. So I try to balance both now. It's been an interesting ride, I guess.
And you recently returned from the Deep Learning Indaba. Tell us, what did you present on?
Yes, They asked me, because I had written some stuff on the issue of bias in algorithmic systems, I was asked to talk about more broadly. Well, if you think about it, the question of bias, or what we call bias or equity in the use of algorithms, it's an ethical question, because there are ethical norms that we're trying to say, okay, do our systems adhere or do they violate those ethical norms? And so in the past year, I've been trying to broaden that discussion quite a bit, not just on questions of ethics of bias, but also questions of ethics more broadly. And so the question becomes, when a commercial entity, when a public entity decides to use machine learning for a particular decision problem, what are the ethical constraints they should be looking into, what are the frameworks for by which they can judge themselves to make sure that they're not violating XYZ ethical constraints. So my talk at the Indaba was trying to make that more formal as opposed to just this touchy feely discussion of ethics that often goes on. Try to give formal, at least concrete frameworks by which people can think about these things.
I like the sound of that. It sounds like there were a number of frameworks that you presented. Was there a specific number of them? Have you kind of categorized the framework space, if you will?
I have not. If I had done that, I think I would be very happy. But I mean, that's like no, that's a huge task. But one of the things I relied on in discussing this was some of the work by Shannon Ballo out of Santa Clara University, and the idea here is that if you try to impose normative prescriptive ethics on the system, that it doesn't always work. Like coming up with the universal ethical law for guiding tech development is not it's not usually an easy or a feasible task. So we went through this process where we went, okay, instead of trying to say this is how this should be, instead of imposing norms on just unilaterally, we tried to elicit the norms from case studies. So the first part of the conversation at the Indaba was, okay, here are here are a couple of case studies where people were thinking about using algorithms in a particular decision process, help people build their intuition on where the ethical flashpoints might be. And then towards the end, we started coming up with frameworks. The one framework I liked that I sort of pushed a little bit was the Belmont principle idea. So if you think about it, when you think about the Belmont principles, it's really the set of principles that came out of a Belmont report back, I think, in the 70s, trying to think through how do you think through the implications of experiments that affect humans. So human subjects protection and stuff. And so part
Belmont?
of the Belmont, yes, Belmont.
Okay.
So part of the understanding I was trying to pull into this space is every time you develop an algorithm to answer a problem that affects lots of people, that's in a sense a social experiment. It's a social experiment that affects lots of human subjects. So it doesn't seem too far of a step to say that you should at least try to judge those new applications according to the Belmont principles. And so we have things like Belmont principles are it's basically your Hippocratic oath in taking it a little bit further. So the basic one is do no harm. Then the other one is make sure your application is just, and then the third one is respect autonomy. Now those sound very abstract and highfalutin, and so one of the tasks I gave myself was to try to um, make those more concrete in the case studies we're talking through at the Deep Learning Indaba. And so the first one, do no harm, was actually interesting because for the most part, we all think we are doing the best we can. So I think we decided that we'd limit it not just to doing no harm, but do no foreseeable harm. Understand that we are not always able to understand the impact a new piece of technology, a new model has on a particular space. So those are the types of conversations. So case studies to prime intuitions, building up, suggesting frameworks like the Belmont principle, at least the Belmont principle frame to help us frame thinking on new applications, and just trying to get general takeaways, general understandings for flashpoints when thinking about ethics and technology practice.
What were the case studies that you went into?
So yeah, let's see. This was like 3 weeks ago. The first one was, I guess, we're trying to. So this is a currently famous, currently popular, or infamous is the right word. Should people use facial recognition technologies for profiling at borders? That was the first one. And where one of the things I was trying to do there, because I work mostly in the United States, the deep learning in Dhaba is a more international community. I sent out a survey to try to get people's people's perspectives on these types of questions earlier on.
Okay.
And I made it such that the survey was tagged based on what part of the world these people, the survey respondents identify with.
Oh,
So we have
interesting.
people like, and the idea there is that we are having this issue of value pluralism. So let's walk through the chain there. The first part of the chain is, well, questions of equity, questions of bias. Those are normative, ethical questions. The second part of the chain is that, well, different parts of the world have different ethical norms by which they live. Right? But it's a very cultural thing. And so part of the point of the survey was trying to elicit any disconnect, any discontinuities in how, say, somebody in Europe thinks about privacy versus, say, somebody in Africa thinks about privacy. So there was in the survey didn't really elicit those sharp disconnects, but in the conversation at the Indaba, there was this sense that some people thought it was perfectly fine, and other people thought it wasn't. There were such privacy constraints on the use of facial recognition profiling that the security benefits or any potential security benefits of facial recognition technologies were overwhelmingly positive compared to the potential downfalls. And so there is not the conversation on that case study illustrated that there was no unified perspective on the use of facial recognition technology.
And so when you have a situation where there's no unified perspective, that seems like a perfect opportunity to try to apply some framework. How did you apply the framework, the Belmont frame, to this particular case study?
So I think it's hard to take an issue on which there is polarization or significant diversity of opinion and try to marshal it into some preferred, whatever that preferred position is. So the procedure, the way forward was to highlight that, okay, you want. So one person brought up the idea that, well, governments are technically more trustworthy than, say, commercial companies in their use of facial recognition technologies, and that is a question that's heavily dependent on what your experience has been with government and what part of the world you're from. And so it's not like you can apply the framework and come up with a single answer that should control.
Mm-hmm.
So my job was to essentially point out that, well, okay, if that's your perspective, recognize that the respect for personal autonomy, that factor, that's the third principle in the Belmont principle, that's not uniformly guaranteed across the world with different governments. And so every time you're making decisions, it's not a question that, oh, you should always use facial recognition technology. It's more a question of, when you're thinking about it, ask these types of questions, and that might help you make more context sensitive answers to those to whether you should use the technology or not.
Is that the same kind of process that you would walk one of your a RAND client through? Do you find that they want more concrete answers, or do they want kind of these experiences that help them understand the scope of the issues?
I think in general, when you're answering questions on behalf of somebody else, there is a balance that needs to be struck. You want to relay strong, useful insights, strong, useful frameworks for proceeding when you leave the room. But at the same time, there is an expectation that you give them concrete answers, or at least somewhat concrete answers to the issues that they're facing. So I try to strike a balance between the two. So when somebody asks me, usually when I'm working so the presentation was a little bit, the deep learning Indaba presentation was at a higher level of abstraction than I would normally work at, because at that point I'm trying to present as much insight, as much abstract insight as possible. In actually talking to clients and actually dealing with governmental clients, I would usually start with a concrete demonstration of, okay, this is a facial recognition technology you're trying to you're suggesting that you might want to use. Well, these technologies have X, Y, and Z characteristics. The most important in the recent days, in the recent months, being that there is a differential error rate that has implications for justice. You can't treat everybody the same. You can't treat everybody equitably, whatever equitably means in that context. And how does that affect your procedures, your operations, and what do you intend to do to address those equity constraints, those equity concerns? So usually I'm working, or at least I'm talking to clients at that level, at a more concrete level of detail. But the goal is not just to give people one-off answers. The goal is to have useful abstractions that help make sense of the world, so that when somebody else comes with a similar type of problem, you can give them interesting answers, informed answers.
What types of clients are these generally, and what types of questions are these generally, and who's generally the actual client? What is their role?
People's experience at RAND differ. It's one of those places where you make your own way. My projects, most of my projects tend to be focused on questions I think are important as opposed to client driven. But in general, RAND as a whole has clients. Our biggest clients are in the half, about just under half our work comes from what we call the federally funded research and development centers. We have three of them, or I think we have four now. We have one for the U.S. Army, one for the U.S. Air Force, one for the Office of the Secretary of Defense, and one for DHS. And so we would generally take on a series of a portfolio of strategic and tactical research problems for those four clients, or subsections, subdivisions of those four clients. On the other hand, we have a health division, we have a justice infrastructure and energy division, we used to have a labor and population division. But in general, those will house our non-defense research questions, and there you'd have people getting grant money from NIH, NSF, or from foundations like the Robert Wood Johnson Foundation or the Gates Foundation to answer some policy relevant question. There isn't as much detail. I'm hesitant to go into a lot more detail about the nature and of the clients and the types of questions they're going into, because that might become a bit sensitive.
Sure. No, that helps me understand the broad process by which folks are coming to you and the types of questions that they might be looking for. At the Indaba, you presented this one framework. Are there other frameworks that you've relied on to address similar types of ethical issues?
So there is one that I tend to. It's not so much a framework. I guess it's a framework in a sense. So oftentimes when people in the fairness, accountable, transparent machine learning, or generally the AI policy space, think about machine learning models. They generally think about it as single monolithic algorithms, single monolithic models that are solving single decision questions. Increasingly, there is this issue of systems level thinking. Like, even if every algorithm in a particular system is unbiased, is transparent, and all that stuff, it doesn't mean that the outcomes from the entire system are necessarily going to are going to be fair, unbiased. And so,
are there specific examples of that phenomenon that come to mind?
It's easier to pay attention to, say, the criminal justice system, where you're always trying to tune algorithms, but then we're always trying to tune algorithms at different parts of the system. So, for example, there's the criminal risk recidivism estimation, criminal risk of recidivism risk estimation algorithms that's been popular, that's been part of the conversation for the past 2 years or so, based on ProPublica's work. And the idea there has always been, we need to fix that. But then there was an interesting conversation that has been happening over the past year, where even if you take this issue, essentially it falls under the umbrella of runaway feedback loops in systems, where because even if you have an algorithm that's performing, say, in an optimal way, historic inequities can cause the algorithm can cause a system to diverge in outcomes for different groups. And so this is sort of like perturbations of the initial conditions for a system for the criminal justice system is causing this vast outsized differences in outcomes. And this happens even if the algorithms themselves, without paying attention to the historical data, the algorithms themselves are trying to behave optimally. And so that's the closest example I've seen. But this behavior seems one of the things I've been trying to do is pay attention to essentially the systems level feedback effect as opposed to just focusing on individual algorithms and systems. So we've been doing this for one of my projects works on this equity concern for the criminal justice system, for insurance systems, auto insurance systems, and for employment systems. And we emphasize this systemic aspect as opposed to this individual decision point aspect. And it's usually a lot more, I don't know, I find it a lot more enlightening than focusing on a single algorithm.
Does looking at it from a systems perspective make these problems more or less actionable for the clients that are struggling to deal with them?
I think it makes the analysis and the discussion a little bit more complex. But the world we live in is complex. The social systems in which these algorithms are operating are complex. One of the things that one of the extra levels, extra dimensions, degrees of freedom that this type of perspective gives you is, well, okay, an algorithm isn't working out so well. You could do one of two things. You could modify the model directly, or you could pay attention to the outcomes and do post hoc modifications, post hoc corrections to the outcomes to try to correct the any inequities in the model. And so an example of where this has gone wrong is so in child welfare systems. I think there was a paper last year or the year before looking into the child welfare data system, and they try to use an algorithm to better estimate the risk of adverse outcomes for children going through that system. They had a situation where the algorithm was doing, in terms of predictive power, was doing pretty well, but in terms of implementation, so you had these social workers taking a look at the algorithm, but because of they don't understand what the algorithm is doing, or they don't trust that the algorithm is taking everything into account, they decide to circumvent whatever recommendations the algorithm gives them. So that's like a post hoc modification to the behavior of an algorithm. If you're focused on the algorithm alone, then you're not going to pay attention to those types of secondary effects that are actually quite important in the real world. And some of the work we're seeing in the criminal justice system is exactly this. The algorithm, so we're doing an analysis for doesn't matter what. So the algorithm was fine, but the post hoc implementation was amplifying very, very tiny difference in ways that were unsustainable. That is important going forward as we start thinking about where algorithms fit in systems. I guess it's a long way of saying yes, it's more complex, but it gives you more degrees of freedom to play, to try to intervene, to correct mistakes.
Right. So, taking a step back in dealing with these kinds of problems, you've mentioned two tools that you use. One is applying frameworks like Belmont. Another is taking a systems thinking approach to looking at the problem. Are there other tools that you use in this way?
I mean, I'm still developing my thinking. Could I say that there are other tools? Not so much. There is another space in which I think people have been trying to think of frameworks, and this is the question of how do you regulate the free use of algorithms? Should you regulate the use of algorithms, and even if you wanted to, how would that work? And so the standard approach to regulation has always been impose laws, give impose laws saying either you can do this or you can't do that. Um, Increasingly, for spaces where compliance is hard to assure, there is the idea of where compliance is hard to assure and where norms are actually more important than hard regulations, the idea of soft governance approaches is beginning to get more attention. I think the regulatory scheme, the frameworks for regulating the proper or the the beneficial use of algorithms, that's still there's a lot there, but there's a lot of thinking going on there, but not much. There isn't as much hard and I guess there aren't as much proven frameworks that I can point to.
If you kind of take that thought exercise around soft regulation and establishing norms and try to take on a broad issue like algorithmic transparency, you end up in likely a very different place than something like a GDPR. How would you like compare and contrast the solution that you might end up with a soft regulatory approach and something like GDPR?
That's an interesting question. I imagine that this is me given my best educated guess, and this is really the correct answer to this. I imagine the thing about soft regulations is that you're trying to build norms and you're trying to build consensus that a broad coalition of people can agree to, a broad coalition of players can agree to. The general thing about broad correlations decision making that require based on broad correlation building is it's going to be a weaker regulatory framework. But if you're working in a highly polarized, highly fractionated space, maybe that's the best you can do. GDPR is interesting because they come at it from a strong normative frame. The idea that the consumer is key, that privacy is not an absolute right, but it's a highly prioritized right, and that the people are central as opposed to the companies. That controls, and it's an interesting and an important perspective. It's a perspective that's been missing from the history of American technology innovation, specifically when it comes to data driven innovation. Uh, but I don't think a sub governance framework would have come up with that. But then you have to worry that sometimes. Okay, here's the driving follow up question: are there spaces where trying to assert a primary normative frame is the best solution to getting compliance? So one of the things about GDPR is there is a question of whether it's going to drive fragmentation in regulation. So you have United States is so California is following GDPR's footsteps, but the United States as a federal system doesn't seem to be able to or want to or have the want to is a strong term to apply to a system. It doesn't seem to be moving in that general direction. China is certainly not moving in the same direction as GDPR. If you try to impose global laws uh, concerning data privacy and you come at it with a strong normative foundation like what the GDPR does, it's an interesting thought exercise to see if that was going to be a viable global approach to regulation.
Right, right. Yeah, particularly in light of the global nature of the technologies that they're aiming to govern. Interesting. And so you spend roughly half your time on kind of these broad ethical and policy issues, and another half of your time at RAND on model development and kind of rolling up your sleeves and building systems or proofs of concepts for clients. Is that work also in this domain? Are you exploring explainability models and transparency, that kind of thing?
I'm a bit more exploratory in my technical work, largely because for me the technical development keeps me honest. And when I try to talk about the policy, regulatory, and ethical framings, if I don't have a technical understanding, I think I'm generally off base if I don't keep that understanding. But for in terms of the actual types of technical models, I tend to pursue. So there's stuff on the explainable stuff. So um, there isn't as much. So DARPA has a program on this. Uh, a program on explainable AI, and we talk to them a couple of times. So everybody talks to them to see what they're thinking. But I tend to my perspective on it is a little bit. I think the models I try to build to address that are a little bit more exploratory than what is probably the rain and stuff. In general, I think where I've spent most of my technical thinking has been on two things. Older models. So there, this issue of explainability in machine learning models. It's sort of I work with people who grew up in the heyday of the 80s AI boom. It's sort of throwing back to that phase. So back then, you had these systems, expert systems that were super explainable. They could do forward inference like most of our machine learning models can do, but they could also do backward inference in the sense that you give it a state of an output state, and it can give you a set of likely input states that have caused, which is one form of explanation. So in a sense, those older systems were better at it than the current systems. And so one of the things I have tried to be explore in the space of explainability is this hybrid of older expert system style models with current statistical machine learning models. This is not like heresy in the sense that you have people like Yuri Leskovec at Stanford doing this thing where he is using decision tree models to try to create a meta model summary of a black box model, whatever that black box is. But my approach is to refer more to what they call fuzzy systems. So fuzzy systems were these old expert systems based model that were used often for linguistic mapping between if and then parts of sets of systems. And so the idea there is to take a black box model, create a gray box model that's a bit more explainable, that sort of summarizes that black box model, and sort of see if you can get better explanations using that gray box model. I think there are a couple of so I mentioned Leskovec's approach to that. There's also Lipton's work on born again networks. I think trying to address it in a similar way. But then these are all exploratory type of models to see what's possible, what's feasible. But the one I actually care about, well, care about is the wrong term. I care about all these models a lot. The one I actually spend a lot of time thinking about is the use of machine learning models, or at least AI style models, to try to answer strategic questions in complex adaptive systems. So you have the situation where you have, let's take, let me try to give a useful example. So I wrote a paper a while ago, I think a year or two ago, where you had a bunch of experts across the world who have thought very carefully about what does it take for a local population to begin to support terrorism. So they call it a public support for insurgency and terrorism model. So you have all these experts pulling their insights to come up with interesting factors and interesting dynamics for how this might work. But that's all linguistic, that's all unstructured data. So one of the things I've been trying to do, and if you think about what RAND does, RAND is very focused on trying to improve decision making, even in those types of complex domains where expertise is rare and is always nebulously defined, nebulous in the sense that it's not crisply defined in terms of data. So I'm trying to come up with models, AI models that take that type of expertise and create quantitative models that allow you to explore and make better strategic decisions. And there's an old model from, actually, it's not that old, it's coming back, it's being used in medical diagnosis. It's called the fuzzy cognitive maps. So it allows you to
fuzzy cognitive maps?
Yes.
Okay.
It allows you to formalize a complex decision space and allows you to explore what are the possible outcomes for different types of inputs. It's actually very interesting in the sense that I also did it I'm interested in this because it allows me to take my quantitative skills and apply to all these areas of research that usually resisted quantitative analysis. So I did it for terrorism stuff, like trying to understand the dynamics of the support for terrorism. I recently did it for a model of Graham Allison's Thucydides trap. I don't know if I always I don't know if I pronounced that properly because I always write it up. I never actually talk about it. It's the Thucydides trap. So the idea that when you have two powers, one rising and one previously dominant, that there is a tendency towards that interaction ending in war. So that's how the historians discuss it. But it'd be interesting to see if there is data to support that. So you have to create a model that represents that dynamics and explore it using clustering based methods to see whether it is actually the case that if the dynamics are such as the historians describe, you get an increased likelihood for war or not.
In both of those examples that you cited, particularly having previously mentioned, unstructured data, natural language, the spaces are so incredibly broad. How do you begin to constrain them such that you can, start to model?
So this is where it's really valuable to work in a building full of non non-engineers, experts and PhDs who are non-engineers and anthropologists. Because what happens is I walk into the building, somebody walks up to me, either a political scientist, usually a political scientist or an anthropologist. They walk up to me and say, "Oh, we have this problem we'll be exploring." Probably over lunch, and we talk through it. And I start thinking, because I'm an engineer by temperament and by character, I start thinking, okay, what types of models, what types of quantitative models can I use to try to say something interesting about this problem they're dealing with? And that's how that usually starts. And going back and forth, checking my intuition, checking my modeling with their expertise. Usually, some sort of a solution, some sort of an approach begins to emerge. And because this type of interaction is actually quite novel, at least it's something people tend to avoid because it's interdisciplinary work is sort of annoying. The languages are so different. It really is annoying. Like I said, I'm not joking on this. So it's much of what I end up doing is really low hanging fruit. Because if I claim to solve the really hard problems in the other spaces, uh, that requires a level of expertise I can't rightly claim to, even if I'm talking to a lot of experts.
Okay.
But those two explanation and fuzzy cognitive maps. Those are sort of my pet projects. I spend a lot of time thinking and developing models on that. For actual work, we do things like recently we had some work on use of reinforcement learning and again and generative adversarial networks to try to develop planning solutions in an agent-based simulation model. So it's that type of stuff that keeps me sharp and keeps me abreast. But it's not. I don't need to produce like production-ready code on that type of stuff.
The whole space of applying machine learning to strategic decision making is quite a fascinating one. Can you maybe take us into a little bit more detail for either of the examples that you gave? What does the data look like that you ended up using? What's the kind of the process?
Okay, so the details. So what happens here is that you're necessarily doing a hybrid type of model. Like you're trying to create a model that takes either equal parts expert elicited structure and data informed structure, and you're trying to merge it into one. The last paper I wrote on this, we had for example, we demonstrated using like explicit to create a quantitative map that we could then use for forecasting and prediction. But then we used Google Trends data to estimate, it's essentially time series data to estimate the strength of certain types of connections. So that would be some type of the technical term is differential Hebbian learning, but in reality, it's just some form of advanced. Advanced is not the right word. It's just an involved unsupervised learning technique. In general, there's that you have and half the time some of the supervision has to come from expert elicitation. So it's sort of a semi-supervised in the sense that there is expert guidance for, say, the directionality of the edges, and so the maps I'm talking about, they're essentially directed graphs. So there's expert guidance on the direction of the edges in that directed graph, and then there is data, unsupervised learning using data to try to tune the strength of those connections. There are other ways to do it. That's the simplest way I've found. It begins to push into the realm of causal inference using Bayesian belief networks. So they are trying to, I guess it's causal knowledge discovery. That's technically what you have to try to do. You're trying to take a bunch. If you had no expert whatsoever, you're trying to take a bunch of data, bunch of time series data, and properly infer using algorithms like junction tree algorithms or expectation propagation. You're trying to correctly infer both mostly the strength of the connections, or if you're doing actual knowledge discovery, the actual graph dependency relationships between nodes and between variables. But because I'm working in a different dynamic, it's just the same algorithms. To use the same algorithms, I have to treat them differently. So I guess the best summary there is it's a form of causal knowledge discovery, causal inference, using a different type of model.
I'm so curious though about the data, for example, in the case of this, trying to, I even forget the way you framed the problem with the terrorism.
Oh, public. So that first paper was that I will not. That was entirely expertise driven. So we had
meaning not data driven.
It's a different type of data in a sense. It's a
meaning, or rather, not statistical.
Not statistical, exactly.
Got it.
So
okay.
It's a form of. We had a corpus, a language corpus. The way technically you'd want to do this in a full project would be to take a natural language corpus that's relevant to the topic of interest, in this case terrorism, identify the relevant keywords. So in this case, there are things like keywords related to how the local population feels the group is, how legitimate they feel the group is, how acceptable the risks are. So you create filters, language filters for those types of identified factors, and then you just basically look for co-occurrence of those filtered terms with other terms, and co-occurrence will increase the more two types of terms co-occur, the more you increase the edge of the strength of the connection between those two things.
So in some sense, it's using kind of almost a graphical approach to sentiment analysis across this corpus.
Yep.
Do you have any recommendations for folks that are interested or intrigued about this, these fuzzy models or applications of machine learning to strategic decisions or game theoretical applications? Where should folks start looking?
So for the fuzzy models, for the fuzzy cognitive maps, I think the best discussion is still, there is a summary book, I think, by Elpeniki Papageorgiou in Greece. It's out there. I can send the link later on. It's just a survey of fuzzy cognitive maps theories and applications, recent applications. On the issue of causal inference, I would say books like what's his name, Pearl's books on causality. In a different tradition, I would say maybe Rubin. It's not Rubin's books. There are a couple of books on propensity score methods that are relevant. So I have a ton of books, but I don't always remember the names, and I'm very trying to put on the spot. On the issue of strategic decision making using machine learning, I think. So that's an interesting area, largely because I feel like that's underserved in the literature. So I refer to I refer increasingly, at least while I was working on that particular project, to a really old book by Axelrod. I believe it's David Axelrod, The Structure of Decision Making. And for that style of graphical coalescing of expert knowledge, I haven't seen as much work, but there are papers. The fuzzy cognitive map papers do that. So we had the first paper did a causal a cognitive map of how the economics and appetite in South Africa are interrelated. So most of the interesting strategic uses of fuzzy cognitive maps are still in papers, I think. There is another area of so this algorithmic game theory idea, the idea of mechanism design to try to solve some of the incentive problems you're seeing. I think Tim Roughgarden, he has a book called Algorithmic Game Theory. Actually, I think that's going to be an increasingly important area when we're thinking about feedback systems and decision making. You're going to need some type of mechanism design process to try to incentivize people to act in specific ways, and you get to with the use of algorithmic game theory, you get to throw in all your quantitative skills to try to improve decision making in a game theoretic setting. I think Roughgarden's book is still the best in that space.
Well, Osonde, thank you so much for taking the time to chat with me about this stuff. Really interesting stuff.
Let's talk about it.
All right, everyone, that's our show for today. For more information on Osonde or any of the topics covered in this episode, head over to twimlai.com/talk/182. For more information on the entire Deep Learning Indaba podcast series, visit twimlai.com/indaba2018. Thanks again to Google for their sponsorship of this series. Be sure to check out the 2019 AI Residency program at g.co/AI Residency. As always, thanks so much for listening, and catch you next time.